Well, it's a bit awkward with a laptop. I've got so many things to juggle. Um, cool. Hey, I'm Jeff from the Metamask delegation team. I'm going to talk about what we've been building with the delegation toolkit. Super excited to cover it. And yeah, thank you, Celine, for getting this all sorted out. It's very exciting. We've got very quickly a 10K bounty split into five pools. One of which is exclusive for your community. The only expectation is that you build a project on top of the delegation toolkit. Um, so jumping in, what's better than simulations? Well, today the best that wallets can do to try and provide some clarity as to what's going to happen when you're interacting with a contract is simulating. We've got something way better. It looks like a simulation. It gives you all of that clarity, except it's guaranteed. So looking at a use case, we put together this experiment for Edge City. The problem space is, users are setting up events, they're having to put down a deposit, and oftentimes people will commit to that, but later on their plans change. They get busy with other things. The person who created this event is then stuck with having to pay the deposit. So with this platform, they're able to create an event. They're able to say how many people they need to attend and how much money they need from each person to be able to commit to the event. And creating this event is free. It's off chain. It's instant. Once they've created this, people can come in here, they can put some USDC in their smart contract account and they can commit to attending these events. When they do that, it's all instant, it's all free, it's off chain, and only once enough people have committed does any money change hands and NFTs get minted to those participants as tickets to those events. And the way it sort of works, if you can imagine, like two people are agreeing to a sort of a contract. One person saying, "I'd like to mint these NFTs, but I need some money for that." The other person says, "I would like those NFTs, and I would pay this amount of money for them." And they might add some other terms. So if you imagine it in the context of a wallet, it might look like simulations. We've got how much you're going to spend and what you're going to get back, except it's guaranteed. So if any of these expectations don't happen, it's not going to go through. So, like looking at delegations versus simulation, in the wild right now, fishers are manipulating simulations. They're front running transactions, which is altering contract state, and people are losing funds. You can't simulate approval signatures because they're approval signatures. So you want to do the simulation ahead of signing that. Uh, Counterfactual contracts, you can't simulate contracts that aren't yet on chain. And to run these simulations, you need huge amounts of really expensive surveillance infrastructure, which that's costs that has to be passed on to the user. And excuse me, that's making these systems, uh, likely to fail if there's an outage or a hack or whatever. These simulations just aren't going to work. Um, Additionally, delegations cost nothing to create. They're instant and off-chain, and they provide strong user-defined guarantees. Simulations still require a user interaction for every transaction that goes on chain, while delegations can enable long-lasting connections through user-defined terms. They can even be produced readably offline, so you could be using like a hardware wallet to produce these guaranteeable commitments. So looking at this again in the wallet, we've got user understandable terms. So like it's really clear what the user is committing to. It's extensible. So anything that can be written as a smart contract can represent one of these conditions. And we're really putting control in the user's hands with guaranteed outcomes. So again, like if any of this doesn't happen as the user expects, then the transaction's gonna revert. So yeah, we're here for a hackathon. So let's jump in to the SDK. Quick refresher on 4337 account abstraction from a very high level. User submits user operations to the bundler. Bundler bunches a bunch of those together, submits them to the entry point. For each of those user operations, a smart contract might be deployed if it's not already on chain. Uh, the user operation is validated by the smart account. That might be validating a signature. There might be some other stuff happening there. Paymaster might commit to pay gas, and then the smart contract calls through the target contract. So our SDK is built on top of VM's account abstraction interface, which gives us a modular architecture for 4337 operations. You need a bundler client, you need a paymaster client, and a smart account. In this case, it's the Metamask smart account. You also need a way to determine fee per gas. And that's a bit where it gets a little bit shaky because that depends on the bundler you're using. They all specify different ways to determine fee per gas. We use Pimlico in our example with the permissionless JS library. You can learn more about that here. And don't worry about any of the links or anything I'm sharing. I'll share a link to the slide deck at the end. Cool. So we've got this demo app here. Hopefully you can still see that. Shake your head if you can't see a gator thing. I'll assume you can. So this is a demo application we've built to walk you through the delegation workflow. It's open source on GitHub, so you can check it out. It's quite a good resource to sort of kickstart your hackathon project. You can fork that. There's also some pretty clear documentation. So working through the delegator workflow, we create a counterfactual smart contract account to represent the delegator. So that's the account that's granting authority, and it happens instantaneously. So that's counterfactual. It's not on chain yet, but we can do things with it. And then we create a delegator account, which is the delegate. That's the account that's receiving the permission or receiving the delegation. Now, the delegator account creates and signs the delegation. So again, this account's not on chain yet, but it's already doing things. It's creating this permission that it's giving to the delegate account. Now we can see here the delegate, the delegator, some caveats, and these are the rules that describe the permission. And we'll get into those in a minute. And we've signed it. Cool. So now we can execute that. So that's where the delegate who received this permission is executing an action on behalf of the delegator. And there's one tricky little thing there where the delegate gets submitted, gets put on chain as part of the user operation, but the delegator who's not submitted the user operation has to be put on chain as a separate call. So we just slip a little call in there into the user operation. But we'll see that in a second. So we see that went through. It was successful. We can run that again because none of these terms say that there's only one time that you can use the delegation. So that was the basic flow of creating smart accounts, creating delegations, and executing them. So let's jump into the documentation. So this is a page describing that example app. I'm going to run through just a couple of key, I guess, gotchas or key things to know. This is architected with like a function representing each of those basic actions. So this is creating a MetaMask account. We call this for each of those accounts in the example. Key things to notice, it's the hybrid implementation. So we've got a multi-sig implementation, which can have multiple signers. We have the hybrid implementation, which has an owner, and it can have passkeys as well, or P256 signers. We create a random salt here. If you want to have a reproducible account, you might just want to use a static hex value there. This is where we create a delegation. Delegations by default are entirely permissive. So unless you're adding caveats to that delegation, you're basically granting full authority to your account. So it's really important to carefully design the caveats being applied to the delegation. Here we're saying the allowed targets is the accounts or the addresses that you can interact with, and the value LTE says how much value you can send. So in this case, we're saying you can send 0 ETH to the 0 address, which is very useful. And then we create a root delegation, passing in these caveats from the delegator to the delegate. Um, the root part of this means that we're inferring the authority from the delegator account directly and not from another delegation that we've received. There's some examples under create a delegation if you want to read up on some more complex scenarios, but I won't get into those now. Here's the function where we actually execute the action on behalf of the delegator. So we create this executions array, which is the function that we're going to execute. And then we encode it in a call to the redeem delegations function on the delegate's smart contract account. And you see there's like a multi-dimensional array here on the delegation chain and the executions array. That's for some more complicated use cases where we can have things like batch execution modes. They're also covered in the documentation somewhere, but I won't get into them today. Just suffice to say that single default mode is the most common case where we're executing a single delegation chain and a single execution. We then have the calls array, which is the calls being encoded as the user operation. So that's calling redeem delegations on the delegate account. And if the delegator has not been deployed, then we need to deploy that as well to be able to validate that signature. And then we submit the user operation. And then we wait for the user operation hash. And that's done. So that's all of the basic workflows. There's more stuff you can read about here. Specifically, restricting a delegation is a great resource. All of the inbuilt caveat enforcers are in there. And up here, you can see the repository. It's not private anymore, but you can jump over to the repository and have a look at that. Let's jump back into our slide deck here. So another gotcha, the .in file. I didn't document it very well. I'm really sorry. You can remove all of those. The only ones that you really need to be able to run that is the bundler URL. You can set that up in Pimlico. You could use another bundler, except you have to replace the gas fee estimated gas fee resolution. And then the public RPC URL is just the Ethereum node RPC URL. Cool. So when you're creating a delegation and when you're redeeming a delegation, oftentimes those are happening in different contexts. I'm creating a delegation and granting them to a different person. So you need to store and transmit these delegations somehow. You can do that however you like, but we have this storage service that makes it really easy. So you can create a delegation storage client. The API keys we've hopefully shared. If we've not, I'll share them shortly. And just make sure you're using the dev environment. Once you've done that, you can pass a signed delegation into the store delegation function, and you get back the hash. That hash is the only thing you need to pass around. You can use it here to fetch the entire chain of delegations. So that's an array of delegations, which may be a single one, or it may be a root delegation and then some other delegations that infer authority from those. But suffice to say, that array is ready to pass into your redeem delegations. Cool. Cool. Couple of keys and tokens things. The SDK is gated. So you're going to need an auth token for fetching that from NPM. And API keys for the delegation storage service. If I've not already shared those with Celine, I'll make sure I do. In the documentation, there's some examples of how to configure Yarn in NPM. They're pretty clear, and you just paste the auth token in there where it says auth token. And the Yarn IC looks like that, and installing looks like that, and then you should be good to go. Here's a couple of resources, my Telegram handle, our email, our team email, and some of those projects we walk through. Feel free to reach out to me if you've got any problems with the SDK. I'm in Chiang Mai right now. I'm going to be in New Zealand time zone in a few days, but I'll do everything I can to help. This here's a QR code to this slide deck feel free to capture that now, but I'll share the slide deck with Celine before the end of the night, and I'm sure she'll be able to share it out with you all.
Okay.
Great. Any questions from anyone?
Any use case that you have in your wish list?
Um, I think I've got a list of them that I can share. The requirement is building on the delegation framework. There's a bunch of really exciting stuff around like social coordination, um, uh, building on top of the Propel app, which is open source. Um, yeah, I'm sure I can share a list with you as well that you can distribute around.
I'll offer a couple, if that's all right.
Please.
Um, hey there. I'm just waking up over here on the West Coast in the States. I'm on the team with Jeff. Um, uh, Obviously, a lot of people are excited about building with AI these days. But usually, when you're working with an AI, you have to either hand it like a whole private key and then it just holds everything, um, or you don't let it do very much. But here you could sign a delegation to an AI and you could give it very specific permissions, like the ability to trade between two token pairs or the ability to, um, issue subdomains of an ENS or configure a given thing or maybe vote on specific DAO proposals or something. So um, yeah, pretty much anything that you do where you sometimes want to let some other person do that on your behalf without having to ask your permission. Another would be if you're in a DAO and you sometimes want to give somebody an allowance where they can do more things without having to ask the whole DAO for permission, like a small travel fund or enough money to run an event or something. That's like another great use of delegations. Um, I also kind of think even just pooling funds, kind of weaving a support network to create long lasting offers of just hey if you need this that can be kind of I think there's actually some really strong potential in kind of open ended social delegation. Um, if you wanted to share token gating, it might be interesting to see if you could use delegations to let more accounts get through a token gate. So you may be able to keep an asset that's cold, but still be able to um, use it in some way from a hot account that's in a website. Um, the, those are a few. But yeah, there's definitely a lot. Kind of anything where usually it's too slow and you want fewer confirmations, or you maybe want more people to be able to do something without getting a wallets in the way.
I have a question, because this bounty is not related to Is Global, but I know that at Is Global, um, when MetaMask and Linear just created a bounty, it's just about deploying the dApp on it. So probably, if we are using this bounty, we have more chance to have as well the bounty at Is Global, probably. I think so. Okay. Um, do you have any other question? I think it's okay. So just share the slide with me and I will upload everything on Notion and on YouTube. So everyone will have the resources and yeah. Are you collaborating with any other communities about your 10,000 bounty for this small hackathon or not?
Um, Not that I'm aware of. Dan might be able to answer that more directly than I can.
Um, I believe it's that 2,000 of it is exclusive for this bounty, for this community,
Yep.
and then the remaining is going to be open to the ETH global community next week. We have
Okay.
another bounty that's running this week for the Edge Lana
Okay,
hackathon.
clear. Okay, clear. Cool. Uh, 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 yeah. For
Oh,
the
and how
someone,
many? So
someone in
yeah, I
the
see Sonia is asking clarity. I think the 2,000. I think we were talking about splitting up between. Was it two or three pots, Jeff? Like I think there was at least two
with two
there.
teams. Yeah.
Yeah, I thought 5 in total. So 1 for Herdal and then 4 for the remaining pool.
Yeah.
Okay, yeah. We can do that. So 1 for pool price and 1 for a team, especially.
Uh, and I see that Ozioma asks if there are other ways that MetaMask can be used apart from being integrated as a typical wallet. And actually, this bounty doesn't really involve the traditional MetaMask wallet. It's really about kind of this embedded smart contract account. So you can use any wallet to deposit funds into it. We're currently working on a permission system, ERC 7715, which will allow wallets like MetaMask and others. We're working with several other wallets to grant permissions to a smart account that's embedded in a website. So this is a bounty really about learning to use one of these embedded wallets before the full permission system is ready.
Yes, Sophia?
Yes, thank you. Thank you for the presentation, guys. So I wanted to ask you regarding of the hackathon. With my team, we are really interested on creating a project for tools for developers. So might be a bit far from using the tool, yet more for like, for example, dependency management. Not necessarily on the smart contract side, but maybe on the project side. Is that something that you could, for example, if we need a mentor or if we need to ask, can we come to you or maybe, for example, ask you for tool validation?
Uh,
Yes, and we have a Telegram channel set up, and we should be able to get you invited there. I wanted to just volunteer a developer tool idea.
Mm-hmm.
So sometimes when you're developing a project, you usually have to have a private key in the root of the project, and then you
Mm-hmm.
have to send some ether to that.
Mm-hmm.
So delegations could give you another way of managing what the project is able to do. If you want a developer tooling that's able to automate some amount of deployment. Um, oh, Jeff, do we have the gas delegation system live in public yet? Oh, sorry. Okay,
no.
so not for paying gas. So that would, I think, be one of the most exciting ones is letting you publish contracts without paying gas. But if there are other things that you want the developer to be able to configure,
Mm-hmm.
like being able to interact with smart contracts without having to have everything in the account, that's a little weaker than the gas. I think the deployment is pretty important. But then again, there are a lot of other things you might do depending on what kind of developer tools you're making. So yeah, we'll
Yeah,
have a Telegram channel.
perfect. I'll meet you in Bangkok.
All good? Okay. No more question? That's fine. Okay. Okay. So I will clarify the bounty on the Notion page, saying that 1,000 will be for the prize pool and 1,000 for one team. Yeah, all good.
Awesome. Thank you very much.
Thank you, you, for that, and to support our community as well. Yes. Okay. So for the Telegram, it's only bypassing Biden or bypassing to a Telegram group for asking for question. Yeah.
Yeah, so we've got a Telegram group set up for the Lana Hackathon. I guess it would make sense for us to set up a group for for this hackathon as well. Or yeah, I don't know. The best way to do that. I'm
Okay, I
not
think I will
wildly
set up a group,
Telegram.
ERDAO, Metamask,
Uh,
if possible. Yeah. Okay, nice. I will do that.
yeah, that sounds ideal.
Okay. All good for me. So thank you very much. I know the next one is Mina protocol, but Mina is still not here. But that's fine. Okay. Ah, Dennis is here. My bad. Okay, perfect. Thank you. So yeah, you're feel free to do whatever you want to do. Oh, you're welcome. Thank you. Thank you, Dan. Bye bye.
Bye.
So Dennis will talk about Mina. Yes, nice.